Okay, so what we're going to learn today is mass to mole, mole to mass conversions, okay? So mass, I'm going to put it like so, mass to and from mole conversion. All right, so first thing we have to establish is, what is a mole? Well, a mole is a word that describes a number, and the number is Avogadro's number. Avogadro is a genius. So what he did is he figured out, if I have, everything we're counting in chemistry is counting atomic mass units. And if you don't know what an atomic mass unit, one atomic mass unit is the equivalent of the mass of a proton or a neutron. Could be the same. So when I have oxygen, for example, oxygen, it has a atomic mass of 15.9994 AMUs. AMU. And its atomic number is 8. Okay? So we're going to come back to this. But this is where Avogadro came in. He said, what does that 15.9994 mean other than it is the average of all the isotopes of an element in their relative abundance and blah, blah, blah. That's a lot. So he started going, hey, wait. How many of those atomic mass units would I need to have 1 gram? And he figured it out. And he said, here's the number. 6.02 times 10 to the 23rd of any atomic mass unit is 1 gram. So this is what we call 1 mole. Now, interestingly enough, mole, some people say, it's the first 4 letters of molecule, right? Get the idea? So it's a relationship to atoms or atomic particles. But it's just a number. So when I say the word dozen, what do you think?
12.
12. When I say the word couple, what do you think?
Single.
2. Right? You would probably single. When I say the word pair, 2 again. Now this is where it gets weird. What if I said few? How many do you think of them?
3.
Yeah, 3.
3. And I've seen the definition of a few is 3 to 7, whatever that means. Okay, so then I thought, what is 8? Anyway, never mind. I digress. I'm on a clock, people. Let's go. Okay, so here's the deal. If I have 1 mole, which is just a number, 6.02 times 10 to the 23rd of anything is a mole, just like 12 of anything is a dozen. You can have a dozen donuts, a dozen eggs. You can have a dozen cars, a dozen giraffes, a dozen elephants. Just like you can have a mole of anything. You could have a mole of eggs and a mole of donuts and a mole of whatever. Just FYI, 10 moles of kilograms is the approximate mass of the Earth. So think that through for a minute. Okay. So if I have 1 mole of oxygen, this is how many grams there are. So if I have 1 mole of copper, that has a mass of 63.546 grams. If I have 1 mole of chlorine, it's 35.45 grams. If I have a mole of sodium, it's 22.99 grams. So you can look at your periodic table, find the mass. We're not going to call it the atomic mass anymore. We're going to call this the molar mass. And molar mass is different in that it's measured in grams per mole. So that tells you how many grams there are if you have 1 mole of that thing. And 1 mole is just 6.02 times 10 to the 23rd of that thing, whatever it is you're counting. Okay, so a mole is just a number, 6.02 times 10 to the 23rd. When you have that many of something, this number tells you how many grams you have. Tell me that's not kind of cool. Because now that number kind of comes to life, because you can go to a scale, pour out some salt. Let me put this together. Na, sodium, is 22.99, and it's number 11. And then chlorine is 35.45, and that's number 17. And if I have sodium chloride and I put it on a scale and I pour it out and I have 58.45, 58.44, grams of this, how many atoms is that? Or how many molecules of sodium chloride? Right? Any ideas? Any ideas? Can you count atoms? So I have 58.44 grams of this, which is those two added together. That means I have 6.02 times 10 to the 23rd atoms. How awesome is that? Now I'm down to counting molecules. Literally counting molecules by the mass of an object. So this is what we're doing. So I'm going to show you one other thing. And this is something that was shown to me by my chemistry teacher in high school 150 years ago.
No racing.
I'm videoing, so we can watch the video.
Josh is going to keep his hands up there for 15 minutes straight.
He's got it. I'm just going to work right here. I'm not even going to erase anything. How about that? Okay, so this was something my high school chemistry teacher showed me. My high school chemistry teacher's name was Paul Loop, by the way. Paul Loop was in his first year teaching when I took chemistry from him. Paul Loop was 23 years old or 22. I can't remember. He was 22 and just turned 23, or he's just 23 when he came in. He was young. And I remember thinking to myself, holy cow, this guy looks like he's 15. It was kind of funny. But anyway, I digress. When I went to college and I took a chemistry class, I sat next to somebody and I showed them this. And they said, wow, how come my chemistry teacher didn't show me that? And I said, because he didn't like you? I don't know. So molar mass comes from the periodic table. And this is grams, moles, and molar mass. So if you're trying to convert from one to the other, this is your conversion triangle. So if I have 58.44 grams of sodium chloride, how many moles is that? Well, you cover up the thing you're looking for, cover up moles, treat the rest like algebra. So you have grams divided by molar mass. Grams divided by molar mass, it gives us moles. Okay, so any ideas? 58.44 grams divided by the molar mass of this, which is what? 58.44. Who's got a calculator? 58.44 divided by 58.44. She's really typing it in. That's one. That's 1 mole. So how many atoms is that? If I have 1 mole, how many atoms is that? 6.02 times 10 to the 23rd. That's molecules. Because this is a. Okay? So, this is how we do our conversions. If we're going to convert to grams, if we know the number of moles, we cover up grams and we take the rest and treat it like algebra. Moles times molar mass tell you how many grams there are. So, everybody clear? Now I need to show you one other thing. We are definitely going to be doing the ones that have the drawn out unit analysis, cancel all the units. We're going to be doing those. But I want to show you the shortcut version first, because the shortcut version really lends itself to what to do next. This is where you start, and then if you remember on this unit analysis thing, whatever the units are here have to match here. And then all you do is whatever the units for the conversion, let's say the unit here is a check mark, this is an asterisk, so the asterisk was canceled, then I got a check mark, then I got to put a check mark here. So that's what you do all the way down the table. We will get back to this. For right now, I just want you to do the shortcut. Okay? Now this is the thing, that's the thing my high school chemistry teacher taught me, was the shortcut and the extended version. So I'm going to do the same for you. Now, what I'd like you to do is on your paper, in your notebook, leave yourself a spot that's going to go all the way across. And it could be at the top, could be in the middle, could be at the bottom, doesn't matter. But I'm going to show you how to put a conversion table in there. Are you ready for this?
No.
I think you are. You keep saying you're not, but I feel like you are. Okay, in the middle of the conversion, let's just imagine this is your piece of paper. And we're just going to go right across the top or in the middle or bottom, whatever it is. We're going across the paper. Okay? In the middle, you're going to write mole. M-O-L-E, and put a box around it. Okay? Put mole in the middle. And no, you're still in your notes. Just the next thing down. Write down mole in the middle, and then you're going to draw arrows out away from mole at the top on both sides. Out and out. Okay? And on both arrows, we want to multiply. Times and times. Then you're going to write 2 arrows that go back in to mole from the outside, and we're going to put divide. So coming back in, we're going to divide. Is that easy enough to remember? When we go out, we're multiplying. We come back in, we're dividing. Okay? On this side, I want you to put grams. And on this side, I want you to put atoms.
Josh, time update. How much? 10:40.
You have 4 minutes, Mr. Allen.
I've got enough time to do this twice. Atoms counts for molecules, particles, any of the little stuff. Okay? So atoms, moles, grams. If we're moving between moles and grams, we're multiplying and dividing by molar mass. Molar mass. And where do I get the molar mass? From your periodic table. You're going to need your periodic table to get the molar mass. Okay? So if I'm going from moles to grams, we're multiplying by molar mass. If I'm going from grams to moles, we're dividing by molar mass. Okay? And from moles, moles just a number, to specific atoms, we're going to multiply by 6.02 times 10 to the 23rd. And then if we go from atoms, the little pieces, into moles, we're going to divide by 6.02 times 10 to the 23rd. Okay? So right now, that's all you need to know. There is another part of this that goes down this way and comes back up this way, but that's about liters of gas at standard temperature and pressure. We'll get to that later. Okay? Who has questions? That was the whole thing. I think we can stop.